Welcome to True Projects. In this video, we are going to explain about the project entitled as a verifiable deletion protocol for enhancing constraints in public clouds. So before getting into the video, let me give you a brief description about the project. The project refers to a secure mechanism that allows cloud users to confirm that their data has been permanently deleted from public cloud storage. The protocol provides cryptographic proof of deletion, ensuring that data cannot be removed after removal. By enforcing strict deletion constraints, it enhances trust, security, and regulatory compliance in public cloud environments. Coming to the abstract states that this project focuses on addressing the major concerns of secure data deletion in public cloud environments. While public clouds provide flexibility and cost savings, users no longer have direct control over their stored data. When data is deleted, user cannot be certain that it has been completely removed from all cloud storage locations. The verifiable deletion protocol proposed in this project ensures that when a user requests data deletion, they receive cryptographic proof confirming that the data has been permanently erased. This increases transparency, strengthens user trust, and ensures that sensitive information cannot be recovered after deletion. Coming to the existing system, in the existing system, data deletion in public clouds is managed entirely by cloud service providers. Deletion is often logical rather than physical, meaning the data may still exist in backups, replicas, or unused storage space. Users depend on SLAs and provider claims without any technical method to verify actual deletion. As a result, there is a lack of assurance that sensitive or confidential data is truly removed. This creates risks such as data breaches, misuse of residual data, and non compliance with data protection laws and regulations. Coming to the proposed system or base paper work, the proposed system overcomes the limitations of existing approaches by introducing a verifiable deletion protocol. In this system, data is securely encrypted before storage and deletion is enforced through cryptographic key destruction and proof generation mechanisms. When a user requests deletion, the cloud provider produces a verifiable proof that demonstrate the data can no longer be accessed or reconstructed. This proof can be validated by the user or an authorized third party, ensuring accountability. The proposed system provides stronger control over data lifecycle management, improves compliance with legal standards, and significantly enhances trust in public cloud services. Coming to the novelty or extension or enhancement or improvement. Firstly, we have done private and public data control extension. As an extension, users can now choose whether their files are public or private. Public files can be shared and accessed by anyone, while private files are kept only for the owners or selected users. This gives users full control over who can see their data. Extension 2, we have done enhanced data security with encryption. As an extension, all user files are protected with AES encryption. This means that even if someone gains access to the cloud, they cannot read the files without the key. So, in addition to verifying deletion, the data stays safe from any unauthorized access. Coming to the modules, first we have registration module. New users or data owners can sign up to the cloud application to start using its service. Next, user login. Registered users can log in to access the cloud application. Next, upload data to cloud. After logging in, users can upload their files. Each file is hashed and encrypted, creating a secure signature that will be used later to verify the file's integrity. Next, anomaly check 1. Before deleting any file, the user sends an anonymous request to the cloud to get details of all files along with their signatures. The user stores this information locally to use for comparison later. Next, deletion request. The user sends a request to delete a specific file from the cloud. Next, anonymous check 2. After some time, another anonymous check is performed to retrieve the current file signatures from the cloud. These signatures are compared with the one saved during check 1. If the signature matches, it indicates that the cloud may have kept a backup instead of truly deleting the file. A mismatch confirms that the file was successfully deleted. Next, credential generation graph. This module compares the computational time required for credential generation in the proposed system versus existing models, showing the efficiency of the new approach. Coming to the requirements, we have both hardware requirements and software requirements. Hardware requirements consisting of operating systems Windows only, processor i5 and above, RAM 8 GB and above, hard disk 25 GB and above. Software requirements consist of application framework is Python 3.7.2, front-end framework is Flask, backend is Python ideally, database is MySQL, front-end technologies which we use to build the front-end are HTML, CSS, JavaScript and Bootstrap 4. To execute this project, first we need to open the code folder which contains the project source code files. Static folder. This folder consists of the files related to CSS, JavaScript and Bootstrap. Templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represents different pages of the website. App.py file. This .py file contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. .db file. This is a database file used to store the information. Coming to the execution of the project, compile the app.py file using the command python space app.py by clicking run server.bat file. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address with the port number of 5000. Copy the local link provided by the framework and paste it in any web browser. I prefer Chrome. This is a front end built using Flask framework. In this page, we have home button, user login button and register now button. So firstly, click on register now button so that the sign up form will be open where you need to enter the username, password, mail ID, contact number, address and user type. In this, we have data owner and data user. We need to log in as data owner and data user. Firstly, let us check with the username for data owner. Click on register so that the sign up process has been completed for data owner. Now, let us do it for data user. Now, click on register so that the data user sign up process is completed. Now click on user login here button. We can log in as data user or data owner by giving the username or password. So let us give the username, then click on login so that we have logged in as a user. The verification hash code has been completed. So for in this page, we have upload data, anonymous check 1, deletion request, anonymous check 2, and credential graph. So first, let us click on upload data so that dataset form will be open where you can choose the file. The file has been chosen and select the access like public or private. Then click on upload the data so that uploadation has been successfully completed. The verification has been generated. Now click on anonymous check 1 so that the data user, the given text file, the verification hash and the date has been generated and access has been public. Click here to get downloaded. The text file has been downloaded. Next, click on deletion request, which means we can delete the file which we have been uploaded. Click here for deletion so that the file has been successfully deleted. And again click on anonymous check 2 so that we can re-verify whether the data is being there in the backup or not. The data integration check has been passed. No backup or erased data detected at cloud. Now click on credential graph so that the graphical representation will be opened. This graph illustrates the credential generation overhead time of the existing system and proposed system. The existing technique shows higher verification time indicating less computational overhead. The proposed technique is slightly lower overhead due to additional security mechanisms such as cryptographic verification. This increase is acceptable as it provides stronger security and verifiable deletion assurance in public cloud environments. Then click on Logout. In the same way, we can log in as a data owner and then upload the data and check the data. So finally, this project ensures that users can confidently verify their data is truly deleted in public clouds. With added privacy controls and encryption, it keeps data secure and gives user greater control over who can access their information. Overall, it makes cloud storage safer and more trustworthy. This is all about your project. Thank you.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.